Hello. It's chilly in Iowa today, so I actually have a D-Max sweatshirt on. Crazy, isn't it? We go from 90 some degrees to 70, but it's Iowa, so what do you do? All right, just a quick reminder, going back to solving logs. Okay, so first of all, remember 2 to the third power is 8. We call this the base, call that the exponent, and for lack of a better term, answer. Okay, what do logs do? Logs eat the answer, and their goal is to spit out the exponent. And then the base just comes down here. And we have a change of base formula, log of the big divided by log of the little, and that on a calculator should spit out 3. Okay, so again, with solving equations, it's usually you like one or the other. Okay, so if you have a single, I don't know why I wrote that. If you have a single log and it doesn't help you, you want to use the definition to go to a single exponential. Okay, and again, you might have to use log rules to do that. So if you have, like log of x and I don't know, minus log of 3 or something equals 8 or whatever, you have to be like, oh, when you're subtracting, you write the word log, it's really division. Still don't like it. This is a single log. You can go to single exponential at this point. So what's my base? Base is 10. Exponent is 8 equals x to the 3. Okay, and then multiply, and it becomes linear at that point. So x equals whatever, 3 with what, 8 zeros? 1, 2, 3, 4, 5, 6, 7, 8. Yes, a huge number there. All right. The other option is if you go between a double log, and I could do natural log or any base log, you go, so you either double log or you take away. Okay, so and when you take away, what you're really doing in a sense is double exponential in a weird, bizarre way. Okay, so for example, there, if you have double exponential, like 2 to the x equal 3 to the x minus 1, you would do a double log to both sides, bring down the x, bring down the x minus 1, and then solve. And it'd be linear at that point. If you have double exponential, like, let's see. So what do we do? Double log, sorry. So say you have ln of x plus 1 and ln of x plus ln of 3. Okay, first of all, you have to get it into the format. So when you add, you're really multiplying, right? And then if you have double log, you can take them away. And the reason is because in a sense, you're doing double exponential, and these cancel out and those cancel out, and you can get the answer. Okay, so again, double goes to double or take away or give, and then rewrite. All right, so again, isolate and inverse, just like every other equation. So subtract 12. This part is just the isolating part. Divide by 2, I'm isolating my function. All right. Okay, so what do I have? I have a single exponential. So I am going to go to a single log. So logs, it's basically I have to use ln. Logs eat answers, spit out exponents. So divide both sides by 2. X equals whatever the ln of 3 is, divide by 2. And I can just leave my answer like that, or you can get decimal. That's up to you. And you can have positive exponents, negative, 0 exponents. That's fine. All right, next one. All right, so first of all, I need either single log or double log. That's it. I can't do adding, subtracting, none of that. So I am going to, first of all, bring back my exponent. So tuck that in. And then on subtracting, you can write the word log once. This is where we use that condensed knowledge. And I have division because it's minus 8. All right, so now what do I have? I have a single log. I got to go to single exponential. My base is what? My base is 10 to the exponent of 7 equals x cubed to 8. All right, how do I get rid of dividing by 8? I'm going to multiply by 8. So I'd be at 8 with 1, 2, 3, 4, 5, 6, 7 zeros, x cubed. And then I'm going to solve this. How do you get rid of cube 8? You cube root. So whatever the cubed root of that is, some decimal, that would be what that equals, okay? All right, if it was a square root, you'd have to get 2 answers, positive and negative. But cubes, the only way to get a positive is a positive times a positive times a positive. So whatever the cube root of that, that's your answer. All right, next one. All right, if you have double log, you're going to go to double exponential. Now, again, technically, this is what, base 10? So I could put a 10 here. And if you have 10 to log base 10, I mean, these inverse each other out, and you get x squared equals x. Most people don't think about that. When they see log of x squared equals log of x, they're just like, oh, well, they both, are spitting out the same, answer, right? I mean, they eat answers, and if they're equal, then the exponents are equal, the answers are equal, and they just do that. But in a sense, you are doing a double exponential on both sides. All right, this is a quadratic. So remember, we like quadratics. I get this. All right, I factor, and I get x equals 0, 1. So I get x equals 0, x equals 1. Now, check your answer with logs. Exponentials are friendly, not so much logs. So log 0 squared cannot have logs of 0. Can only have logs of positive numbers. So that's going to be good, and that's going to be good. So I only get one answer there. I don't get two. All right, here what do I have? I have double exponential. So I need to do double log, and we do natural log to both sides. And then remember the exponent comes down, so x plus 1, ln of 2, 2x comes down, ln of 3. Okay, distribute. And this is just linear at this point. I know it doesn't look like it, but ln of 2 is just a number, just like pi. All right, I want to go from having 2x's to 1x. That means you have to bring them over and factor. So I'm going to bring this guy over as a negative. Then I'm going to bring that guy over. Okay, so that, bring that guy over as a negative, and then there. All right, so now to go from 2 to 1, I'm going to factor out my x. That's the only way that's going to happen, because those are not like terms. So what is that? Minus 2 ln of 3. I'm just pulling that x out front from both of those. And then to get rid of this multiplication, I'm going to divide. So x is equal to this number, negative, what is it? ln of 2 divided by all of that, ln 2 minus 2 ln 3. And if you hate this, what you could do is when you bring it down, you could go ahead. I mean, if you want to write, like 4 decimal places for that and 4 for that, you could just do decimals. But if you want an exact answer, then you have to kind of do it this way. All right, so again, let's kind of just highlight, kind of again, how do you do these? Okay, how do you solve every equation in the whole wide world? You isolate and do the inverse. Okay, that's what you do. Isolate and do the inverse. Okay, what do you do after you do that? Well, you look at what you have. If you have a single, at that point, you have a single exponential, you are going to go to a single log. Logs eat answers. They spit out the exponent. The base comes here, and that would be ln of, 17 over ln of 2, or log of 17 over 2 is going to equal x. Okay. All right. The reverse of that happen if you have a log that you don't know what you're doing. So you have x plus 1 equals 3. Single log equal, you can't solve this. So you're like, oh, I don't like this. It's a single log. You're going to go to a single exponential. The base here is, and I could have a different base. I could have 4. My base is 4. My exponent is 3. X plus 1. What is that? 64 equals x plus 1. Subtract 1. X is 63. Now, you might have to condense to get to this point. So you might have log of x minus log of 2 equals, say, 3. And then you're like, oh, I need to get a single log by using the division rule. And you can get there. Or, oh, I have log of x plus log 2 equals 3. All right, well, when you add, you multiply. And then you get a single log. So it's possible you might have to do some other stuff. Okay, now what? What's the other option? Double exponential. So you have something that looks like, this. They don't have the same base. So you're like, okay, I need to do a double log. And we usually use natural log. You could use the other one too, and then you bring this down. Bring this down. Again, order of op matters. You need parentheses there. Then you distribute. distribute, okay? So you get x ln 2 ln plus what, ln 2? And then you get 4x ln 3 minus ln 3. Again, how do you solve for x? You bring your x's to one side. And let's see, let's subtract that guy over. So negative ln 2, negative ln 3. And then again, you're going to factor out your x, bring your x out. And then you're going to divide both sides by that. Okay, that's a double log. Okay, now again, what if it's the reverse, or double exponential, sorry. Double exponential, you use a double log to solve. Okay, what if it's the other one? Well, happen if you have a double log. Okay, again, it is a log on each side. You can just take it away. So you can either give a log to both or you can take away, because what you're really doing here is you're making it a double exponential. It was a double log, you're doing that. And again, these are inverses of each other. So you just get that, okay? And then you would bring over, you know, see if you could factor, do something with that, right? Okay, and you know, if not, there might not be a solution. Okay, so remember, logs can only have positive numbers, not even zero, you know, when you're done. Okay, and I made that up so it doesn't look like it's going to factor very nice, so I'm just going to leave it. Now, again, before you get to this stage, you might have something where it's a 2 and an x and a plus, maybe a natural log of 5, or who knows, and then over here you might have natural log of 7 or something like that. You have to use your combination to condense. Bring the 2 back in, adding, you're like, oh, that's really a multiplication problem. Then you have double log, you can take it away. Or again, you could do double exponential, which makes it go away. And then you would be like, oh, okay, so then I have 5x squared equals 7, divide by 5, x squared equals 7/5. Now, square root both sides, and remember, you typically get two answers. Square root of 7/5. Can't have negatives. Now, notice this is actually okay here as far as with my squared in there, but again, the original problem didn't have the squared in there. So the negative square root of 7/5 is not going to be nice. Okay. But you know, you got to kind of watch those things a little bit. Okay. I went to show you Desmos on that last one. That's doing something weird in the corner there. All right. There you go. So I went ahead and graphed the last one we just did, and you can see the value right there. And so on a calculator, if you take the square root of 7/5, you get 1.183. That's the one answer that we just had on that previous one. And I don't know why I'm frozen here. I'm going to stop for a second. I got rid of the frozen me in the corner. Oh, maybe I didn't. I don't know if you can see it or not, but whatever. Just remember, single exponential goes to a single log, single exponential. If you have double log, and you might have to condense to get it, double log, go to double exponential. If you have double exponential, add double logs to both sides. And these guys can look a little weird because, again, if it's something like this, technically you can either just take the, you know, just look and say, oh, these are the same because my bases are the same.